All right, welcome to Chapter 8, Section 5, called Surface Area of Cones, and this is for Math 8. So a couple things you'll see on your screen here. The first thing you should see is a due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. You always have unlimited attempts, meaning that you can come in and try your homework, tests, and quizzes as many times as you would like. Number of questions, that just tells you how many questions are in this particular assignment. Grading policy is best score, so whichever score is the best one is the one you get to keep. Partial credit is enabled, so that means if you answer one of 3 questions correctly, then you get credit for 1 question, or however many you answered correctly. Down here it says, please remember once you start the homework, you must finish it before you can work on anything else. That means once I click start here, down in the bottom right corner, I will see a submit assignment button. No matter what, I want to make sure that I click this button when I'm ready to leave this homework assignment. So whether I've answered anything at all or if I've started some of these, I want to click that submit assignment button. If I have a green check mark up here, so I've done the problem and I've clicked check, it's going to save my place. I'm not going to have to repeat those. I will pick up exactly where I left off. If you haven't started them or you don't have the green check mark, it's going to make you redo those. So just keep that in mind. But if you don't click the submit assignment button and you just close the screen or close your computer, Alex is going to assume that you want to leave this attempt open instead of closing it. Remember, you have unlimited attempts, so you don't need to leave it open. So go ahead and click the submit assignment button so it doesn't lock you out of every other assignment. The other big thing that clicking the submit assignment button does is it affects the grade book so that your teacher can actually see what you've been working on. Until you click that button, basically your account's on pause. We just can't see anything. All right, so along inside here we have explanation, example, and message center. Explanation tells you you're going to lose your question attempt because it's going to give you the solution to this question. So it's not going to give you the answer and then let you come type it in. Sorry, that's not how this works. Example gives you an example of something very similar to what you're looking at, shows you the formula in this case that we need to know. So for this one, we're doing the volume of a cone. So I'm going to go ahead and write that over here. Volume of a cone, we need to know this, 1/3 base times height. And I believe we'll look at the y on the 1/3 on the next screen, on the next question here, number 2. So this is just a formula we need to use to work this guy out. So you can look through that example. Once you're happy, you can scroll down to the bottom and look through the whole thing. You can look at another example if you'd like also. And you can also message your teacher directly from the screen so that we know where to help you because it attaches a picture. All right, let's go ahead and get started on this guy. So I wrote down the basic formula. Volume equals 1/3 base times height. And a lot of these 3-dimensional objects have base times height in their formula for volume. And what this capital B for base means is the area of the base or base shape, whatever it is. So if we're looking at a cone, the area of the base shape in this case is a circle. So I want to know, how do I find the area of a circle? Well, the area of a circle is pi r squared. So I need to know what I'm looking at. I need to know how to find the area of multiple different shapes in order to do this. Now, if it's a cone, which for this problem it should always be a cone, it's going to be a circle on the bottom, no matter what. So I'm going to rewrite this as volume equals 1/3 pi r squared. Remember, that's the base. I'm just replacing b with pi r squared and then times the height. So the height goes from the center of the circle up to the point on the cone. So that it has to be perpendicular like this in order for this to work. All right. So we have v equals 1/3. And they're asking us to write the exact volume in terms of pi. So they actually want us to leave the pi symbol there. And then r, well, they give me, r stands for radius, by the way, in case this is kind of a little bit more of a review. We've been doing a lot of these circular type shapes, but just to review that, r means radius. Well, if I'm looking at a circle like this, radius goes from the center of the circle to the side. So this is a radius. They're giving me that the entire thing going across here is 10. Well, if I go from side to side through the center, this is called a diameter. But if we kind of think about what did I just say about a radius goes from the center to the side, from the center to the side. So these are both radii. There's just 2 of them. So whatever they give me for a diameter means it has 2 radii, and they have to be the same amount. That's the definition of a circle. This circular line on the around out here is the same distance away from the center at all points. That's quite literally the definition of a circle. So if they give me the diameter, I can divide that by 2 to get the radius. So 10 divided by 2 gives me 5. So my radius is 5. So I have 5 squared times the height is 6. Okay, so now I have 1/3 pi 5 squared. This is PEMDAS. I have to do exponents first. So, PEMDAS. I don't have any parentheses to deal with, but I do have exponents. So it's 25 times 6. So now I can do multiplication or division from left to right. So I'm going to go ahead and look at this first and say, you can actually reduce first. So 1/3 means I'm dividing by 3. So I can take 6 and divide it by 3 and go, well, that's 2. 6 divided by 3 is 2. And now I can do 25 times 2 is 50. And then pi is just going to drop down here. Remember, we're not changing pi to anything, and we're not typing pi into a calculator. They want us to leave it in terms of pi. I can even see that I can click on it right here. So the answer is 50 pi. And then we also need to make sure we put a unit on it. We started with 10 feet and 6 feet. So this is going to be 50 pi feet cubed. This is 3-dimensional. So that's what this 3 means here. It's telling me it's 3 dimensions. It's actually kind of like a 3D object. That's exactly what that means, is it has length, width, and height. It's kind of a container, something it can hold space. It's not just a flat object that's 2-dimensional, length and width, or a 1-dimensional that just has length or just width. So we want to make sure we're paying attention. How are they asking me to type this answer in, number 1? So first thing is they wanted me to leave it pi, and then I also need to make sure I click the correct unit here based on the number of dimensions I have. And since 5 has feet on it and I squared it, this would be feet squared. This has feet on it. So I come down here and I go 25 feet squared times 2 feet. Well, that would get me 50 feet cubed. 2 plus 1 is 3. So it's that exponent idea. You can actually use that on the units as well. So it's just kind of a couple of different skills there thrown together. All right, let's go to the next guy here. I'm probably going to need a little bit of that, but it's all right. What's this in the middle here? It's interesting. I'm not really sure what that little guy is here. I think that's one of the tools here it's like open and just staying there, but that's okay. All right, find the surface area of a rectangular prism. Be sure to include the correct units in your answer. So one thing we do want to pay attention to on this one, let's see if I can find it real quick. If we're looking at a rectangular prism, kind of like this guy, so it's a box, right? And if I look at the net for a box, which means that we break it open, and we've done this a few times in class, so I'll click play here so we can actually see it. So here it is, it's folding back up, but I can cut the box away and I can unfold it too, so that I can actually see that it makes kind of this, a bunch of boxes, right? And this box here, or this square rectangle, matches this rectangle, because this would be the left and the right side. This, or the front and the back, actually, if I thought about that a little bit more. This little one and this little one would be the left and the right side. This one in the middle is the bottom. This one in the all the way on the side here is the top, if you watch it fold again. So I can see there's the left, back, front, and then it was the right and the top. So it's made up of a bunch of rectangles. Well, if I want to know the surface area is the area all the way around. How much surface does it have? So I need to know the area of all the surfaces. So when I do this, I want to make sure that I'm looking at this box. I'm going to try to draw it real quick as a net. So I have this guy. It's a little bigger there, I think. Something like that. That's probably not quite right. I'm drawing these a little bit funky, but I'm being a little bit too picky about it here, I think. All right, so we have something along these lines, and then I'd need the top part extended out here. So I took this left side here, which has a length of 3 centimeters, and I just laid it down. And then this bottom part here, which is this area here, I folded this flap down. So this is 8 centimeters. And both of these are 3 centimeters, by the way. It doesn't matter which one, because if I folded these back up into the box, they'd both be on this corner. And then I have 4 centimeters over here on this one, which is the bottom line here. So this is 4 centimeters. So I need to be able to fill in all these boxes though, when I'm doing this. And one thing we need to remember about a rectangle is opposite sides are congruent. So if this side is 3, so is this side. If this side is 3, then I can go across the rectangle and this side is 3. And then same thing here. If this, because it's the height, this is 3, well this would be the other corner there. It's this back corner if I folded them back up. So this is also 3, and since I'm sharing here, I'll share here. I can go across. This guy would be 3 centimeters. And same thing, these are folded corners that would come together. So these are all 3. So now let's deal with the lengths going across here. Well, if this one is 4, and we think about all of these lengths going across this way, they would all have to be the same length in order for it to make this nice rectangular prism. So this would have to be 4 centimeters, 4 centimeters, 4 centimeters, and 4 centimeters. All of these would all have to be the same. And this line would actually be the one that comes all the way over here to meet with this side. When I fold this all the way back up, they would meet right there. Again, just kind of visualizing the net. How do I fill this in? And then we can also look at this 8 centimeters, same thing. This length down the bottom would have to be the same on all these lines going in the same direction. So I'd have to have 8 centimeters, 8 centimeters, and 8 centimeters, like that. And it might be easier for you to picture the actual box here. I'm not super great at drawing boxes, but I can give it a try here. Like this. All right, something along these lines. So we had 3 centimeters, and we had 8 centimeters, and we had 4 centimeters. So here it is. So remember, if this is 8, then all of these are 8. I'll just put them in blue, going like that. All of those same lines would be 8. And then if this guy is 4, all of these same lines going in the same direction would also need to be 4, like this. So all the green ones need to be 4. And then I'll just leave these guys in red. So we have 3, 3, 3, and then my one dotted line back here is 3, right? So it just depends on which one's kind of easier for you to look at. Maybe the three-dimensional is a little bit easier to look at as far as, how do the lines go around. So now let's go ahead and start calculating some of this out. So we're going to look at the different parts of the box. The front of the box and the back of the box, or rectangular prism, are going to be exactly the same. So if I have the area of the front, I can just multiply that by 2. One for the front, one for the back. So this is front / back. So it's a rectangle or a rectangular prism. That means all of the shapes are either going to be rectangular or cubes. If we had a square on any of these sides. We're not going to have a square on any of these sides because we don't have any sides that are all exactly the same. This is 3 by 4. Remember, green was 4. And this is 3 by 8. That's definitely not a cube. A cube needs to be the same length and width. So to find the area of a rectangle, we go length times width. So if I want to do the front or the back, I'm going to have 3 for the height, or I can say length and width if I'm thinking of it flat. So 3 times 8, or 8 times 3. So that equals 24. I have a front and a back, so I'm going to multiply by 2, so that gives me 48. All right, and then I have the left / the right side. So let's look at that. So if I look at the left side here, I have 3 and 4 for length and width. So that gives me, oh, I started writing at 3, dang it. 3 times 4 gives me 12. Remember, there's a left and a right, and they need to match. Because that's the idea of a rectangular prism. It's the same shapes across, or the same rectangles. All right, so that's 24. And then I also have the top and the bottom. So there's 6 sides in total. Here's one side, and then when I multiply by 2, that's 2 sides. Here's 4 sides, because I multiplied by 2, and then when I multiply by 2 on this last one, I'll have 6 sides. So it's a 6-sided figure. All right, so the top, I have the green 4, and I have the red 8, or blue, sorry, blue. I meant to redo that in blue, but the red line's still kind of there. So the blue line for 8 and the green line for 4. So 8 times 4 equals 32 times 2 for both top and bottom. They're both the same rectangle. I have 64. All right, so this is the surface area of kind of each matching group. To get the total surface area, I need to add them all together. So I'm going to have 8 and 16, because 8 plus 8 is 16. 4, 5, 6, 7, and then 7 plus 6 is 13. So 136, and this is going to be centimeters squared, not cubed. This is an area, meaning we're talking about length and width, which is exactly what we did a whole bunch of times, right? Length times width. We're not talking about the volume. We're not talking about what the box can hold, just the amount of space the flat walls take up, I guess, is a kind of visual way or a way to describe that. All right, so I have this squared, check. So this is the idea of surface area. We're just looking at the surface on the outside. How much area does it take up? All right. So, okay, so we're looking at some lateral kind of cross sections. So if we take a look, I think there was one like that on this one. So this is the only one that I could kind of find a little manipulative for. But what it does is it kind of lets us see when we cut a section out. So it's like a plane that's going right through. So I know that went down through, but it's like we're cutting through it. And what we're asking is what shape does it make in the center here? So if it's parallel with the top like this, so like it's flat on the top right here, it's going to cut a section that looks just like the shape of either the top or the bottom. Again, kind of depends on the shape there, what we're looking at, if it's a cone or a cylinder or a rectangular prism. But I can also kind of change and tilt it here, which would change definitely, the shape that it's going to be making if I tilt that. See, I can even make a triangle out of it. Now, when we do that on here, we're doing a much more basic idea. We're just going straight through it. So really what we want to do is look at, if I'm going straight through it, it means it's parallel with the top, and it's going to cut out whatever shape top that is. So in this case, it's going to cut a triangle out. If we were to peel this away, it would look just like the top here. It would just be a little shorter now. So this guy, a cone's a little different because the tippy top is just a point. But once I get past that top point, it's going to be a circular. And so we're actually focusing on the circle at the bottom. So again, if we were to take this cone off the top where it cut through, we would have a circle left over. And then if we go straight down through a cylinder, so this is a little different because we're not going through the parallel to the top or the bottom, which would be circles. Instead, we're cutting straight through the cylinder. So let's see, if I draw the cylinder like this, you can kind of see it a little bit nicer. Maybe if I can kind of draw it nicely like that. So here's my very funkily drawn cylinder here. And if I cut straight through like this, through the top, what I'm doing is I'm going to focus on that shape that it would make cutting through the top, like this. So I'm literally going to cut it in half, and I'd end up with 2 halves of a cylinder, and the shape that it would make would be a rectangle. Alrighty. Okay, so that was section 5. If you noticed, it was called surface area of a cone, and we did not do the surface area of a cone. For whatever reason, Alex did not have that topic in there for this section. So that's why we practice surface area of a rectangular prism, just to get that idea across. It's the surface area. Surface area of a cone is a little different because we have, a different shape there. So we have a different formula. That might be why it wasn't throwing it into that section. we'll definitely practice more surface areas as we move forward here. All right, so that was section 5. I will see you in section 6.